Every year, American gardeners spend over $50 billion on fertilizers, soil conditioners, and compost products that arrive in plastic bags, deplete within weeks, and require repurchasing every single season. Nitrogen that vanishes in the first rain. Phosphorus that locks into the soil and never reaches a root. Compost hauled in by the truckload from facilities that charge by the cubic yard. Meanwhile, a single piece of perforated pipe buried in your garden bed, costing less than $2 at any hardware store, can produce the most nutrient-dense fertilizer ever tested by soil science, delivered directly to plant roots every single day, manufactured for free by an organism that has been building the world's most productive soils for over 300 million years. The synthetic fertilizer industry generates $230 billion annually by making sure you never connect a garden pipe to the workforce that makes it run. The record opens in 1881. Charles Darwin, the most famous naturalist in history, spent the final years of his life not studying evolution or natural selection. He spent them studying earthworms. His last published work, The Formation of Vegetable Mold Through the Action of Worms, documented decades of meticulous observation and concluded that earthworms are among the most important creatures in the history of the world for the role they play in building and maintaining productive soil. Darwin measured the rate at which worms pull organic material underground, calculated the tonnage of castings deposited per acre per year, and demonstrated that worms had buried entire Roman ruins under layers of biologically processed earth over the course of centuries. His final scientific statement to the world was not about the origin of species. It was about the organism that feeds them. So what happened to that knowledge? In 1909, Fritz Haber synthesized ammonia from atmospheric nitrogen. Within a generation, the earthworm was replaced by a bag of chemicals. The fertilizer industry taught gardeners to feed plants directly with soluble nitrogen, phosphorus, and potassium, bypassing the biological system that had built every productive acre of farmland on Earth. The worm became irrelevant. A $230 billion industry was born, built on a single myth, that soil fertility must be purchased, applied, and repurchased every season. The living factory underground was shut down and forgotten. A 2014 meta-analysis published in Scientific Reports, analyzing 58 controlled studies spanning over a century of research, confirmed that earthworm presence in agricultural soils increases crop yield by an average of 25%. A 2019 meta-analysis published in Agronomy for Sustainable Development confirmed that vermicompost, the castings produced by earthworms, significantly improves plant growth across virtually every crop category tested. A 2023 study in Nature Communications estimated that earthworms contribute to roughly 6.5% of total global grain production. The knowledge was never lost. It was simply made unprofitable to remember. Until now. Here is the system they never told you about. The pipe. What it is and how it works. The device is a section of standard PVC pipe, 4 to 6 inches in diameter, cut to approximately 30 inches in length. You drill holes across the lower 18 inches of the pipe, roughly 1/4 inch in diameter, spaced 1 inch apart. You bury the pipe 18 inches deep in the center of your garden bed, leaving the top 12 inches above the soil surface. You cap or cover the top with an inverted flower pot, a piece of screening, or a loose-fitting lid to keep out flies and rain. That is the entire construction. Total cost at any hardware store is under $2. What you have built is a worm feeding station. You drop kitchen scraps, vegetable peels, coffee grounds, crushed eggshells, and fruit waste directly into the pipe throughout the week. The organic material sits inside the perforated section below the soil line. Moisture from the surrounding earth keeps the scraps damp. Microbial colonization begins within hours, and then the earthworms arrive. This is where the biology takes over, the worm highway, how earthworms find the pipe. In 2011, a study by Zerbs and colleagues, published in PLOS One, one of the most widely cited open-access journals in the world, demonstrated that earthworms use chemical odor cues to locate and move toward decomposing organic matter and the microbial colonies that develop in it. The worms are not wandering randomly through the soil. They are following volatile chemical gradients, scent trails released by bacteria and fungi as they break down organic material. When you fill a buried pipe with kitchen scraps, the microbial bloom that forms within the first 48 hours sends a chemical signal outward through the soil in every direction. Earthworms within a 3 to 4 foot radius detect that signal and begin migrating toward the source. The worms enter through the drilled holes in the buried section of the pipe. They feed on the microbial film coating the decomposing scraps. They process the material through their digestive systems, and they deposit their castings, the most nutrient-dense natural fertilizer ever documented, both inside the pipe and outward through the holes into the surrounding garden soil. The castings spread through the root zone in a radius of 3 to 4 feet around the pipe, delivering nutrients directly where plant roots are actively feeding. The system is not a compost bin. It is a biological reactor embedded directly in the growing zone. The worms do not need to be managed, turned, harvested, or maintained. They regulate their own population based on food supply. They migrate in when food is present and spread outward when the pipe is empty, distributing castings through the entire bed as they move. The castings. What the worms produce and why nothing synthetic competes. Worm castings contain 5 times more nitrogen than ordinary garden soil, 7 times more phosphorus, and 11 times more potassium. But the numbers alone do not explain why castings consistently outperform synthetic fertilizers with far higher NPK ratings in controlled trials. The explanation is not chemistry. It is biology. Each gram of high-quality worm castings contains billions of beneficial microorganisms, bacteria, fungi, protozoa, and actinomycetes that form symbiotic relationships with plant roots and improve nutrient uptake by up to 40%. The castings also contain humic acid, which improves soil structure and helps plants absorb minerals more efficiently. They are pH neutral. They cannot burn plants regardless of concentration. Unlike synthetic fertilizers that spike and crash, the microbial populations delivered by castings remain active through an entire growing season, continuously mineralizing nutrients on demand in response to root signals. The 2014 meta-analysis by Van Groningen and colleagues confirmed that the positive effects of earthworms on crop yields are strongest when organic residues are present in the soil, exactly the conditions the pipe system creates. The yield increase disappears when synthetic nitrogen is high, suggesting that earthworms work by unlocking nitrogen from organic matter, a function that synthetic fertilizer bypasses entirely. In other words, the more you rely on synthetic inputs, the less your earthworm population contributes. The more you feed the worms, the less you need the bags. The 2019 meta-analysis by Bluer and colleagues, published through Agronomy for Sustainable Development, confirmed that vermicompost significantly improves plant growth metrics across dozens of crop types, consistently outperforming equivalent applications of synthetic fertilizer, standard compost, and unfertilized controls. A 2003 study by Kaui and colleagues documented worm castings increasing soil microbial activity and plant nutrient availability beyond what conventional compost achieves with measurably higher enzyme activity in soils amended with castings. The pipe does not manufacture a product. It manufactures a population. That population manufactures fertility on a continuous basis, day after day, season after season, without a single additional purchase. The USDA endorsement. What the government already confirmed. In 2023, the USDA People's Garden program at USDA headquarters in Washington, D.C., published a direct endorsement of in-bed vermicomposting using buried, perforated containers. The Natural Resources Conservation Service described the method in detail. Drill holes in a lidded bucket. Bury it to the rim in your garden bed. Add bedding material and 200 to 300 composting worms. Feed the system with kitchen scraps. The worms process the material, spread nutrients through the surrounding soil, and regulate their own population based on food supply and temperature. The USDA publication confirmed that worm castings are high in plant-available nutrients and improve both soil structure and water holding capacity. The agency specifically recommended the buried container method as an accessible, low-cost approach to producing vermicompost directly in the root zone of actively growing plants. The method described by the USDA is functionally identical to the pipe system. The only difference is the shape of the container. A bucket, a pipe, a section of drain tile. The biology does not care about the vessel. It cares about the food supply and the access points that let worms enter and castings exit. The fact that the USDA endorsed this method in 2023, and it still does not appear in any major fertilizer company's recommendations, is not an accident. The method replaces the product, and the product is a $230 billion industry. How to build and run the system. The construction takes 15 minutes and requires no special tools beyond a drill. Buy a 30-inch section of 4 to 6-inch PVC pipe from any hardware store. Drill quarter-inch holes across the lower 18 inches, spaced roughly 1 inch apart in rows around the circumference. The more holes, the more access points for worms. Bury the pipe 18 inches deep in the center of your garden bed. If your bed is larger than 6 by 6 feet, install 2 pipes spaced 4 feet apart to ensure full coverage. Cover the top of each pipe with an inverted clay pot, a piece of window screening secured with a rubber band, or a loose-fitting cap that allows AIR exchange but blocks flies and rodents. Add a few inches of damp shredded newspaper or cardboard to the bottom of the pipe as initial bedding. If your garden soil already contains earthworms, they will find the pipe within 2 to 4 weeks through the chemical gradient mechanism documented in the Zerbe study. If your soil is biologically depleted and you do not see worms when you dig, purchase 200 to 300 red wigglers or European night crawlers from any worm supplier and add them directly to the pipe with the bedding. They will establish a population that self-regulates from that point forward. Feed the pipe with vegetable scraps, fruit peels, coffee grounds, tea bags, crushed eggshells, and small amounts of shredded paper. Avoid meat, dairy, oil, and large quantities of citrus. Each layer of food scraps should be topped with a thin layer of dry bedding material, shredded leaves, newspaper, or cardboard to maintain airflow and prevent odor. A properly maintained pipe produces no smell whatsoever. If you detect odor, you are overfeeding. Pull back on volume for a week and add more dry bedding. The pipe processes roughly 1 to 2 pounds of kitchen scraps per week, depending on worm population density and temperature. In warm months, processing accelerates. In cold months, it slows. The worms migrate deeper in winter and return to the feeding zone as soil temperatures rise in spring. The system runs year-round in zones 6 through 10 and operates seasonally in colder zones, resuming automatically when spring arrives. The castings accumulate inside and around the pipe continuously. You never need to harvest them. The worms distribute the processed material outward through the drilled holes directly into the root zone of surrounding plants. Within a single growing season, the soil within a 3 to 4 foot radius of the pipe will be measurably darker, looser, and more biologically active than the soil beyond that radius. By the second season, if you have installed adequate pipe coverage across the bed, the entire soil profile transforms. The economics. Why the fertilizer industry does not want you to do the math. A single pipe costs under $2. A starting population of worms costs $10 to $15, or nothing if your soil already has them. The food supply is kitchen waste you are currently throwing away. The system requires no electricity, no water input beyond what the garden already receives, no turning, no harvesting, and no seasonal reapplication. Once installed, it runs indefinitely. Compare that to the annual cost of synthetic fertilizer for a 200 square foot garden bed. Bagged fertilizer runs $20 to $40 per season. Premium compost runs $30 to $60 per cubic yard, and most beds need at least 1 cubic yard per season. Specialty soil amendments, worm castings sold in bags, liquid fertilizers, and microbial inoculants add another $20 to $50. The average American gardener spends between $70 and $150 per season on inputs for a single bed. The pipe replaces all of it. Not partially, entirely. The castings produced by the worm population deliver a complete nutrient profile, a living microbial community, and continuous soil structure improvement, all manufactured on site from waste you were already producing. The annual operating cost after installation is $0. The fertilizer industry generates $230 billion annually. Every dollar spent on a buried pipe is a dollar permanently removed from that revenue stream. The product is not consumed, it is alive. It reproduces. It does not need to be repurchased. That economic model is the exact opposite of the one the industry was built on, and it is why you have never seen a perforated pipe advertised next to the fertilizer bags at your garden center. But it survived. The knowledge of in-ground worm composting never disappeared into corporate archives or regulatory filings. It survived in the most unlikely place, the final published work of the most famous scientist in history. Charles Darwin's 1881 book on earthworms has been continuously in print for over 140 years. It is freely available in full text through Project Gutenberg and Darwin Online. Every claim he made about the role of worms in building and maintaining soil fertility has been confirmed and expanded by modern research. Van Groningen's 2014 meta-analysis confirmed the 25% yield increase. Zerbez's 2011 PLOS-1 study confirmed that worms navigate by chemical gradient toward decomposing organic matter. Bluin's 2019 meta-analysis confirmed that vermicompost outperforms synthetic fertilizer across crop categories. The USDA endorsed the buried container method in 2023 from their own headquarters garden. Indigenous farming communities across the Americas understood the relationship between buried organic waste and soil fertility for thousands of years before Darwin documented it. Terra Preta sites in the Amazon, where ancient civilizations buried charred organic material and food waste directly into the soil, show extraordinary earthworm activity and fertility that persists 2,000 years later. The method was never invented. It was observed, practiced, forgotten, and rediscovered. Today, the buried pipe system is accelerating across home gardens worldwide. Not because the industry promoted it, because gardeners who spent years buying bags of fertilizer and watching their soil biology decline started asking why a $2 pipe and a handful of worms could do what $100 of products never could. The silence around in-ground worm composting is breaking. You can grow what they made you buy. Start with one pipe in one bed. Feed it for one season. Watch the soil around it change color, texture, and productivity. Then install a second pipe, then a third. Within 2 seasons, your garden will be running on a self-sustaining biological system that costs nothing to operate, produces the most nutrient-dense fertilizer ever tested, and never needs to be replaced. The $230 billion fertilizer industry profits from a cycle of seasonal dependency they designed. One $2 pipe breaks that cycle permanently. The knowledge was never lost. It was waiting in Darwin's final book, in the USDA's own garden, in the soil beneath your feet, in the hands of farmers who never needed a bag of anything to grow food. If this seed was finally freed for you, subscribe to Hank's gardening journey and hit the bell. Every like and every share helps break the silence. The next seed breaks free soon.